So I'm Chris Vervais. I'm a director in the Site Reliability Engineering Group for Splunk Cloud. And I've got with me a member of our team, George Starkey, who's a senior site reliability engineer on the team. So similar to Walmart, I've got something I've got to say ahead of time, which is forward-looking statements. Basically, I might gaze into the crystal ball and it might be wrong, and you can't hold it against us. So with that out of the way, one thing I want to acknowledge as well, this is a team effort. It's just George and I standing up here, but we represent the efforts of a number of folks back at Splunk working on this. We've got, I'd love to put folks' names up here, but I don't want to give the recruiters and the fishers an unfair advantage. So I'm not going to name everyone, but they know who they are. And one important point about our team as well is that we're distributed. We have folks in Seattle, we've got folks in Portland, which is where George and I are from. We've got folks here in the Bay Area, Sydney, Australia, Gujarat in India, in the UK and London, DC, Plano, and Denver. So we've got a lot of folks spread around and we have to work together. And while a POC existed beforehand, we really kicked this off about a year ago, and it happened in the Puppet offices up in Portland. Myself, George, a member from the UK team, and two folks from Puppet Services, which is a good point to make that we have worked together throughout this project with Puppet Services. We've had folks from Services embedded in our team, advising us, training us, helping us on best practices, and really upping the level of knowledge. And it has made a big difference in the delivery and the stability of the group. So let me give a quick intro to Splunk Enterprise Cloud. It was launched in 2013, and it was Splunk's response to the change in demand from, hey, we want to buy shrink-wrap software, we want to run it on-prem, build teams around it, to we want the benefits of Splunk without having to go through all that. And so Splunk decided we're going to offer it as a service. It's hosted in AWS, so we're taking full advantage of all the services we have in AWS. And this reduces our headaches and keeps us focused on managing the service because we're not having to manage all of that. Similar to Splunk Enterprise, but it is not literally running Splunk in AWS. It has its own cloud-specific functionality, features, etc. And while I can't give out specific instance counts and numbers like the gentleman from Walmart before, what I can give out is publicly, we announced last year, $94 million in revenue for cloud. So it is a serious business, it is important to Splunk, and it's critical to our success. So, why Puppet? It's easily summed up by saying we were investing too much versus the return we were getting. We needed to rethink the approach to set ourselves up for success in the future, where we want to be. The system that was present before us, it was focused on provisioning, not on management. And so management of what was provisioned was being handled by an agentless, procedural-based system, not declarative, not here is what we want it to be. And we were starting to see the diminishing returns. And so what are those returns that we're after, and where does Puppet fit into that? First, we want to scale to tens of thousands of customers, both large and small. Splunk Cloud is not a one-size-fits-all service. We want to meet the needs of all of our customers, both today and in the future. And so we need to cover a large swath of data ingest volumes from gigs to terabytes and beyond. And we don't want our management system being the bottleneck to that. We don't want it to be in the way. And so we need the flexibility as well so that we can quickly accommodate new features and services. We also want predictable outcomes always. And predictability is key for us at this scale. Our customers use us for mission-critical use cases. Delivering unpredictable outcomes does not instill confidence in them. for those mission critical use cases. And they go from security to IT ops, business analytics, the whole swath. And predictability for ourselves as well. We want a system that enables us to deliver features and change in a predictable way. We don't want to be surprised. We have stakeholders as well, and we want to be able to tell them with confidence, yep, this can get delivered at this point. And we want to deliver positive outcomes for customers and for Splunk. We work for Splunk, and we want to keep our customers happy. And so when they succeed, we succeed. And so the system needs to be an enabler of that and not a blocker. And so the flexibility and adaptability that we need plays that role. And so we need to support the features of today as well as what's coming in the future for the service, what we might not know about. And so if we design the system only about what we have today, we're going to lock ourselves in and not be able to deliver what we want in the future. So, scaling tens of thousands of customers, this system is focused on managing the environment. And so rather than building a provisioning system and then bolt on management later, we've built a management system where provisioning is merely creating an instance and having Puppet run on it, and it makes it match the rest of the environment. And provisioning a stack, which is what we call it, the collection of Splunk services for customers to use, is only 0.01% of the life cycle of a stack. Typically, we do 3-year deals in Splunk Cloud, and so provisioning is just a small part of it. The rest of the time is on managing it, patching, upgrading, tuning, failure recovery. That's where most of the time is spent in the life cycle of the stack. And Puppet helps us to achieve this by managing the environment, preventing drift, and making changes easy to deploy across the entire fleet, regardless of size. And George will go into some detail later on how we do that, how we scale it. It keeps the environment consistent and in our intended state. I'll keep saying this. This is one of the keys to the success. We can't scale where we want to be if every stack is bespoke, or said another way, a snowflake. We don't want our environment to be a blizzard. We also can't have the stack state be based on when it was provisioned. We need it to match the rest of the environment so that we can have predictable change through it. Version source control. Many reasons for this, but all code for config and code is in a version controlled repo. This helps us to enable appropriate change control because we offer SOC 2, PCI, HIPAA compliance levels. And so we have to be able to track changes back. It's fully auditable. We have auditable. We have a record of change, and it's a 2-key system. So the person submitting the change can't be the one to also approve the change. We've got linting and validation built in. Rollback is as simple as reverting the PR. And George will also be talking about that. Fault tolerant. Stuff happens. We don't want our responses to predictable failure, like an instance failing, to create a bunch of work for a human, create toil work. So all infrastructure we have is deemed disposable. If an instance dies, automatically a new one's created, Puppet comes along, makes it match our intended state, and there's no human intervention. This keeps our mean time to resolution low, extremely low. And putting the work in up front, which was one of the things we did with the Puppet infrastructure, pays dividends later. Because it's not, okay, we've got it standing up, all right, now we can start building off of it, something's failed, now what do we do? We're not having to worry about that. And it gives us also the ability for the parts of the infrastructure that support it to auto-scale, since adding another instance is no different than replacing an instance. It's the same thing. So compile masters, for example. That's what we use there. And so for predictable outcomes, again, having a consistent environment leads directly to that. A consistent environment means there's less unique cases to account for, less to test for, and less planning. And it puts a limit on the unknowns. Less work to design the tasks to account for uniqueness as well. We don't have to deal with a ton of variance. And for our security posture as well. We have, because we've put this all into code, dev, stage, live environments, that we can have a high degree of confidence looks just like the production environment. We can do the testing in dev, and it's relevant. We can do the testing in stage, and it's relevant, because we've gone and invested so that we can punch these environments out left, right, and center. If we need a new one for a specific feature we're working on, it's not a problem. And because it's coming out of the same code base we're using in production, it is relevant. That limits the surprises and increases our predictability. We have a promotion process of moving from dev to stage and then to production, so that we have confidence as we go through the various environments that it is going to be okay. And the staging environment is also where our internal customers use for their development, their testing, and so we treat it as a prod-like environment for them too, and so that they can have a high degree of confidence that how it works in that environment is how it's going to work in the production environment. And so by the time the change reaches live, hey, we're good. We're not worried. We're not keeping up at night. And we can control the rollout too. We have that option. We can roll out the changes to the production environment all at once. We can go a availability zone at a time, a region by a time, or even a stack at a time. It's all in our control, depending on the change and how we want to roll it out. And again, if we want to roll back, all we do is revert the pull request for that change. So, delivering positive outcomes for customers and for Splunk, the customer experience. Fault tolerance there is key. With that reduced MTTR, customers have confidence in our service that we can support their mission-critical use cases and keeping the service continuity going. The change is predictable, and so we can say with confidence to them, yep, we're making this change. Here's what we expect to happen. It's not going to interrupt your business. And it keeps our velocity high. So as customers start asking more, we can deliver faster, more predictable. And a faster time too for our internal customers of new Splunk features into cloud. And scaling the business. Splunk is a business. It's a corporation. And so we want to make sure that we're not adding people to the operations process along with every customer. We want those efficiencies of scale, and with Puppet we can do that. And the automatic failure detection and remediation means less support contacts too. And so the benefit of this resilient system pays dividends in other parts of Splunk as well. And it makes us all more productive because we can focus on the larger picture, drive more scalability. We're not mired down in toil work, doing rote, repetitive, error-prone things. This is the next point. We're not toiling. We're not just going and repairing broken systems, things like that. We're focused on the high-value problems of both Splunk and our customers. And with that, I'm going to give it to George.
Thank you, Chris. Thank you for all of you being here and those of you online. I wanted to make a shout out that a lot of our successes over the last year or so have been built on efforts made by the community. So we're not the only ones that succeed in this case. So I'm going to go over in the next few minutes a lot of reinforcing the ideals that Chris had mentioned on scaling positive customer results and predictable outcomes. So I'm going to go over what I coined a technical journey to consistency, or how to make the abyss stop staring back. So early on in our process, in order to reach a goal of scaling to tens of thousands of nodes, we didn't want to have to worry about our back end. We didn't want anybody to have to be up at night worrying about the tools that are supposed to make everybody's lives easier. Because of this, we built self-healing infrastructure for Puppet. Our master is running Puppet Master, Cert Authority, PuppetDB, Puppet Console. In order to have that mostly stateless self-healing, we leverage auto-scaling groups a lot in many layers of our infrastructure. The Puppet Masters are all in single-member auto-scaling groups. By having this, we have AWS doing health checks to detect failures, whether it be hardware, software issues, service failure, what have you. We automatically reprovision those whenever we detect these failures. Those replacement nodes on the Puppet Master will automatically remount the EBS volumes, the disk volume, that holds the various Puppet softwares. We then reutilize the various Puppet tools for reinitializing those, configuring them to be back to their consistent states. At that point, we also have Git that pushes via Code Manager to make sure we have all of our Puppet code in place on the database. At this point, we know that we have a single source of truth, and the master itself is clean. But you can't scale a single source. That's where we bring in the layer of the compile masters. These are in variable size ASGs, depending on the amount of infrastructure we need in that location. Whether it's in a region, in a particular VPC, etc. Again, AWS is monitoring the health of these. Similar checks, slightly different in most cases though. Since this is where we are scaling our processes, these are have to be completely stateless nodes. They're not pets. So unhealthy nodes are automatically detected and replaced. Our bootstrapping scripts install Puppet, check into the master. The masters are segregated by various network boundaries, because we don't want dev nodes checking into live or anything like that. Our auto signer also has pieces in place that will block unnecessary calls, or unwanted calls rather. So now that we have a clean backend and it's scaling for all of our volume that we're expecting, we then started to discover that, in order to deliver multiple customers that are all unique, we needed to have a lot more interaction with the system, not just the static set that we have. Due to this, we split out the Puppet control repo from our data sets. This allows a clear separation of code and data in our infrastructure. The control repo can handle the logic, and it completely separates that from understanding how your configurations that you need in place get there. That allows our engineers to focus on their strengths. We have some strong Puppet people in our organization, and we have a lot of Splunk knowledge in our organization. Those don't always cross. Sometimes they do. To this end, we have built out types and providers for a lot of the Splunk infrastructure on the back end. This includes things like managing user accounts through the UI, various Splunk configurations that were historically only manageable through CLI calls or API calls. And we also utilize the roles and profiles methodologies quite heavily to ensure that as we're spinning up new nodes, they're always delivering the correct service that we expect them to. So the other side of that coin is IRA. This can be reviewed by Splunk experts without having to be able to read Puppet manifests all the time. Puppet manifests are great. They're very declarative. You know exactly what they're going to do. But if you're not strong with Puppet yet, you may not quickly be able to read through it. For this, we manage a lot of our configs through higher layering. This gives us the ability to quickly put the configurations in place that we need based on environment, region, specific customer, even specific nodes if we need to. Basically, this gives us the ability to do any changes we need in the infrastructure without having global changes. So now that we have a stable backend and we have a way of interacting with it, we need a way to protect ourselves from ourselves. Due to this, we have a lot of linting and spec tests running on all of our infrastructure. Since Puppet is a very node-centric management software, we noticed that it was difficult to define a distributed software environment by managing individual nodes. Due to this, we added in our spec tests. Each developer can build a feature branch, test, and install a distributed install on their own stack. This gives an engineer a holistic view of everything that they're doing and how it's going to interact with the rest of the infrastructure. In the old system, this was not always easy to do. Now we can build out individual stacks within minutes. We have linting and tests, spec tests running on every commit. This will test the individual module that you are working on. We also have one-server checks that will test holistically the entire repo, how your module is going to behave alongside others, also how the roles and profiles will affect it when they're applied. And we force all merging to be blocked until these tests pass. So, your code is not the only thing that can cause problems in your environments. Due to this, we apply the same type of principles to our data sets. In our Hyra repo, we run linting and data validations, making sure it's going to parse properly, making sure that we're not putting any settings that we previously noticed were wrong. And on top of that, we have peer review by Splunk experts that will validate that the intent of our changes matches what is written in the code. With that, early on in the project, we were running at breakneck speed, and we have one module for managing all of these services. We're now in the process of splitting that out, and we now have two separate modules, one for managing the Splunk software itself, and one for managing the management of those things, specifically for cloud. Which leads us to Puppet Forge. We're releasing a Puppet module specifically for Splunk management. The initial release will be able to manage standalone instances, distributed indexing clustering, certificate management, license management, inputs, outputs, along with most every other Splunk configuration that you can find. Currently in development for this module, we will be having support for search at clustering. And since it'll be on the Forge, we're opening up to community input. We have the knowledge of running this service, but we're not 100% experts in the field. Our enterprise customers find problems all the time that you don't encounter unless you're in a particular situation. Chris?
Thank you, George. All right, so for questions, we'll be on Slack, Puppetize live channel, along with everyone else. If you need to register, slack.puppet.com to go there. I'm C. Vervais, and he's Dr. Random, other known as George. Thank you.
Thank you.